Hey Math Kids, today we're going to talk about arithmetic series. We're in your book in chapter 5, section G, and we'll be starting on example 25 after we talk about a few things. So first off, let's talk about what a series is. It's just when we add up some or all of the terms in a sequence. And so we're going to focus on finite first. So all finite means is it doesn't go on forever. It's the opposite of infinite. And so we have two ways to do that. This is found in your book right above example 25. So if you want to look at it in the book, that's fine. Now just a quick refresher. This S sub n is the summation of the sequence, which is a series. N is the number of terms that you're going to. So if you're going from 1 to the 10th term, n would be 10. U1 is the first term, and whoops, this was supposed to be UN. UN is whatever term you decided to go to. So this n is the same as this n. Down here, similar. We talked about this n, Sn. U1 is the first term, n is the number of the term that you're going to. D is going to be the common difference. So if we go on to example 25, it gives us this sum. And it wants us to add up this sequence to 50 terms. And so, because we don't know the 50th term, which would be this, we're not going to use this one. So we're going to focus on this bottom one. So we're going to say S sub 50, because we're adding to 50 terms. N is 50, right here. Then 2 times the first term, plus 50 minus 1, and then we multiply that by the common difference, which we see we're just adding 3 each time. Okay, so we set this up, now we just need to simplify it. So 50 cut in half is going to be 25. This is going to become an 8. This is going to be 49 times 3. And if we, let's just keep going with this. So if that was a 50 and we times it by 3, it would be 150, but we're losing 1 each time we go. So that's going to be 147. And then if we add 8 to that, that's going to be 155. And then if we multiply those together, we get 3,875. Feel free to use a calculator to aid in that simplification. But let's move on to the next one. So this time it wants us to find the sum of this. So this time we don't know how many terms we're going out to. But since we know the first and the last term, we're going to use this formula. Once again, that's just written in your book above example 25. So we're going to just find S sub n. But we need to find n. So we're also going to try to figure out what n is using something we learned in a previous video, which I'll just write it out. So we know that u sub n is equal to u sub 1 plus n minus 1 times d. In this case, our last term is 141. Our first term is -6. We don't know n. And then our common difference, we're adding 7 each time we go. So that's 7. Now we just want to solve. So we're going to add 6. Add 6, 147 equals n minus 1 times 7. Distribute that 7. 147 equals 7n minus 7. Add 7 to both sides. So we get 154 equals 7n. We divide by 7, divide by 7. And so n is equal to 10. Or no, sorry, 22. I don't know what I was talking about. So n is equal to 22. This isn't our answer, but we will use it in this formula now. So if we fill out that formula, we're looking for the sum to the 22nd term. That equals 22 over 2. And then we times that by the first and the last term, or first term added to the last term. Move that over just a little bit. Now we just need to simplify that. 22 cut in half is 11. And then 144 minus 6 is going to be 135. And if we multiply those together, we get 1,485. So the sum of this, if we added all those terms, including the ones that are represented by the ellipses right there, it would equal 1,485. Okay, now we're going on to example 27, and it says an arithmetic sequence has a first term of 8 and a common difference of 2. The sum of the terms in the sequence, so u, n, equals 170. Find the number of terms in the sequence. So, the sum is 170. Okay, so we're given this information and it's asking us to find n. So we are going to use this formula. And let's plug in what we know. So we know this is 170. We know that d is 2. We don't know what n is. We know what the first term is. And once again, we don't know what n is. Okay, so we don't really need any of that information. It just comes down to solving now. So distribute the 2 right here. We get 2n minus 2. Multiply these together, we get 16. And then we still have, there should have been a parenthesis right here. And we still have n over 2. What I'm going to do is I'm going to clear the fraction. So I'm just going to multiply this side by 2 and this side by 2. And then I'm also going to combine the 16 and the negative 2 into a 14. Let's see, that is going to be 340. Okay, now we distribute the n. So we get 14n plus 2n squared equals 340. So that's going to create a quadratic. So we need to get everything onto the same side. Since we have an n squared and an n, we know it's quadratic. So I'm going to order this how we order quadratics. Okay. We can divide everything by 2, which will make it a little bit easier. So n squared plus 17n minus 170 0. And then hopefully, this is a t factoring, so we'll try that. Well, one thing that comes to mind is 17 and 10, would that work? Oh wait, this isn't 17. This is just 7. Sorry, 14 divided by 2. Just 7, not 17. Okay, so 17 and 10. To make positive 7, we use a negative 10. So we're going to say n plus 17, n minus 10. That's still equal to 0. By the zero product property, we can break this up into two equations. N equals negative 17, n equals 10, and negative 17 doesn't make sense for n because n has to be a positive number, and so n equals 10. So essentially what that's saying is there are 10 terms in that sequence. And that is everything in that section. If you need additional help, come to Math Lab. But until then, calculator.